about our BMMA 1333 assignments regarding free body diagram representation from an actual structure. First of all, I would like to apologize for the bad lighting. This is due I'm only able to record this video at night to prevent unnecessary sound in the background because there's construction going on nearby my house. Without further ado, these are the members of my group.
Okay, before we go through the assignment, let us discuss about the objective. The objective of this experiment to ensure that all students are able to draw out the details of free body diagram from the actual structure. Besides, the students also be able to develop the equilibrium and analyze the force member from the real structure. Okay, so next, Haikal will show us about actual structure that we have choose.
Okay, now I'm going to show you guys the structure that we chose for our assignment.
This is the overall structure that we chose for our assignment, which is a cottage. However, we only investigate the upper part of this cottage. Let me zoom it for you. See, now let's find out what we can get from this structure. Hence, this is the overall free body diagram for our structure. We assume that the force that will produced by the roof is 2 kN, and we also assume that AX and CX equal to 0 since there is no external force acting horizontally.
Then, without further ado, let's move on to the calculation for each system.
Okay, now let's start by finding CY and AY. Okay, for CY we need to use moment. Okay, sigma MA equal to 0, so that negative 2 times 4 minus 2 times 8 minus 2 times 12 minus 2 times 16 plus CY times 16 equal to 0, so that CY equal to 5 kN. For sigma FY equal to 0, AY minus 2 times 5 minus CY equal to 0, AY equal to 0 minus 5, so that AY equal to 5 kN.
So the first point will be point A. This is the free body diagram at point A. We assume all the forces are going outwards. As you can see, there are two unknown variables such as FAB and FAD and two known variables which is 5 kN and 2 kN. To be able to resolve these unknown, we need to use the equation of equilibrium, which is summation of Fx equals to 0 and summation of Fy equals to 0. At summation of Fy equals to 0, we substitute all the forces related to y-axis, such as 5 kN and 2 kN, and the resolution of FAD, which is FAD sine 30. Therefore, 5 minus 2 plus FAD sine 30 equals to 0. But before that, we already assumed that any forces that going upwards is positive and downwards is negative. So, when we solve this equation, we are going to get FAD equals to negative 6 kN. Lastly, FAD equals to 6 kN, which means the negative value represents compression, or the force is going inwards. This goes to summation of Fx equals to 0 too, which the equation will be FAD cos 30 plus FAB equals to 0, and the value of FAB equals to 5.2 kN, which represents tension. These steps applies to joint C too.
At point B, we use method of section to cut the structure as shown in the figure. Next, we make the equation of equilibrium of moment at point B. Then we're gonna get the FES equal to 4 kN tension. Move on to point F. First, we make equation of equilibrium of Fx and we find out that FEF equal to FFD. Hence, FFD equal to 4 kN tension as well. But for Fy, since we know the value of both FEF and FFD, we're gonna solve this equation and we're gonna find that FFB equal to 6 compression.
Let's start to finding at joint B. At joint B, sigma Fx equal to 0. 5.2 minus 5.2 plus FBE cos 13 minus FBE cos 13 equal to 0. FBE equal to FBD. Sigma Fy equal FBD sin 13 equal FBE sin 13 plus FFB plus 0. 2FBD sin 13 equal to 6. FBD equal to 6 kilonewton tension. FBE equal to 6 kilonewton tensions. By drawing the free body diagram of the actual structure, we managed to develop the equilibrium equations. We have analyzed the force member and come to NN, the force that support the structure in equilibrium. The structure of the roof can support the weight of the roof. In a microlab, in a nutshell, the objective of this assignment is achieved.